Hello everyone, in this lesson we're going to be talking about solving systems of equations using the elimination method. So, like the substitution method, the elimination method is also an algebraic method for finding the place where two lines would intersect on a graph. Alright, so let's follow the following steps to solve this system of equations over here. Alright, so it says, step 1, line up the x's, y's, and constants. Of course, they're not always x's and y's. They could be a's and b's or m and n's or any other letters, but you're going to line up your two variables and your constants. So what does that mean? So for us, this is already done. X is above x, y is above y, and constant is above constant. Roughly they're off by just a little diagonal there, but they're right above each other in order in this system of equations. Okay. So that's done for us in this first example. Now we're going to do something that's very unusual and unique. We're going to either add or subtract the equations in order to eliminate one of the variables. So what does that mean? So if I look at these two and I kind of use the little pink highlighting marks to almost create three different addition problems here. I'm going to take and I'm going to add these two equations together. So in the first pink highlighting, I've got 7x plus negative 7x. Well, that's nothing. That would get rid of all of our x's. And that's the point. We eliminated the x's if we added them together. Now we have to continue with the rest of the equation. 8y plus negative 5y is 3y. And 3 plus 6 is 9. So we added, step 1, 2, and 3, the x's, the y's, and the constants there. And all of a sudden we have a incredibly easy equation to solve. We're ready to divide both sides by 3. And we get y equals 3. And that seems a lot quicker than a number of other methods. And if we think about solving this equation by substitution, we'd have to divide by 5, 7, or 8 up there, and we're going to get some messy numbers for sure. So we already found half the information. We found the y value. So let's go ahead and plug that into our first equation. 7x plus 8 times 3 equals 3, and that's 7x plus 24 equals 3. We'll subtract 24 from both sides. We get 7x equals negative 21. Divide both sides by 7, and we get x equals negative 3. So our solution is negative 3, 3. Terrific. Now, you might be thinking, that seemed too good to be true. Well, it was a little nice that when we looked at the equations, we had 7x and negative 7x there. So we had to kind of identify that pattern was happening, and that told us that adding them would eliminate the x's. So let's look. We said in the step 2 that we could add or subtract. So let's go ahead and look at example 2 down here. Now, if I went and added, the 6x and the negative 9x, that doesn't look like that's going to cancel. And if I added 3y and 3y, I'd end up with 6y. So that wouldn't cancel. So this time, instead of adding the two equations, we're going to subtract. And if it helps, make little highlighting marks to make like 3 subtraction problems. Now, a little bit trickier here when we subtract, because we need to do 6x minus negative 9x. 6 minus negative 9 is like 6 plus 9, or 15x. 3y minus 3y would give us nothing. That's what we wanted. Negative 30 minus 15 is negative 45. The toughest situation is when the second equation has a negative or a minus in it, and we are subtracting. Then you have to really remember minus and negative is like adding. Okay, but we are now down to a much simpler equation, and we can divide both sides by 15 to get x equals negative 3. Wow, so much easier. Okay, so we can plug that in. 6 times negative 3 from our first equation plus 3y equals negative 30. So that's negative 18 plus 3y equals negative 30. We'll add 18 to both sides. 3y equals negative 12. Divide by both sides by 3, and we get y equals negative 4. So our answer is negative 3, negative 4. Great. So going back to the original problem, remember we recognize that we had the same variable with the same coefficient and the same sign here. So subtracting was a good situation there. If we compare that back to number 1, here we had 7x and negative 7x. So adding them was probably the best solution right there. All right, I do want to draw our attention to a problem like number 8 here. In number 8, the first equation is in close to standard form. The second equation is in a weird non-form. So we need to make sure that we line things up. So I'm going to go ahead and in the second equation add 12 to both sides. That'll at least get my constant all alone like in the first equation. So 12 equals y plus x. That's our second equation now. So hopefully you can see that if we just kind of flip this around, we'll get x plus y equals 12, and that's more lined up with negative 2x plus y equals 3. Okay, great. So we're looking at this, we have them lined up, and we're trying to decide what to do. Add, subtract. Well, we see y in both equations has a positive 1 coefficient, so we are going to go ahead and subtract. So 1x up there minus negative 2x is really 3x. The y's are gone, and we have 12 minus 3 is 9. Divide both sides by 3, and we get x equals 3. All right, if we go up to our first equation, negative 2 times 3 plus y equals 3, we get negative 6 plus y equals 3. If we add 6 to both sides, we get that y is equal to 9. So our solution is 3, 9. So notice in this situation, again, we had to line up things before we could actually begin to using the substitution method. Okay, great. So let's go ahead and scroll down a little bit to our next page, and pardon the typo there, we are doing elimination still. All right, so if we look at this, looking at our coefficients here, if I add or subtract, I am not going to get anywhere. I'm not going to eliminate any variables. So you might notice that the x's, the top equation, 8 is kind of like double 4. So a sneaky thing we can do, because we can do anything we want to any equation as long as we do the same thing to both sides. So I'm going to take the second equation and I'm going to multiply the whole thing, both sides, by 2. Might not have been obvious right away, but if I do that, the second equation will become 8x minus 16y equals negative 40. So that's from equation 2. So what I'm going to do is I'm going to now take equation 1 and just recopy it down underneath. Negative 8x plus 3y equals 1. Well, now we see that we have two equations, and the x's here are the same coefficient except for opposite signs. And so then that means if we add these equations together, we will eliminate the x's. So adding the x's, they're gone. Adding the y's gets us negative 13y equals negative 39 on the other side. Okay, we'll divide both sides by negative 13. Divide by negative 13, and we get y equals 3. We can plug that back in. Negative 8x plus 3 times 3 equals 1. So negative 8x plus 9 equals 1. Subtract 9 from both sides. Negative 8x equals negative 8. Divide both sides by negative 8, and we get x equals 1. Great, so our answer, our solution is 1, 3. So let's put back into words what we did. So we're looking at a situation where there is no common coefficients. If adding or subtracting will not eliminate any variables, first we need to multiply one, or as we'll see in a situation, or both equations by, we'll call it a scale factor, some number that will make them cancel out. Okay, so let's go ahead and try another example. Let's look at number 16 here. So if I look at 16, I can see, 8 and 3, they don't really look like they're too happy, but 6 and 12 look closer to happy, if that makes any sense. Now, I could multiply the second equation by 2 and make both equations have 12x. Personally, I prefer adding the equations better. So I'd rather have not 12x in the second equation, but negative 12x. So to do that, I'm going to multiply the second equation by negative 2. Again, that is a personal choice. You could have multiplied by just positive 2 to get 12x, but if we multiply by negative 2, we get negative 12x, we get negative 16y, and we get negative 60. So that's our second equation. I'm going to rewrite the first equation down below it. 12x plus 3y equals 21. So now I don't have to subtract. Subtracting is sometimes a little bit more confusing. I can add. So the x's are gone. The y's, that's negative 13y equals negative 39. Divide both sides by negative 13. Deja vu, anyone? And we get y equals 3. Okay, we'll go ahead and plug this back into our first equation here. 12x plus 3 times 3 equals 21. And that means 12x plus 9 equals 21. Subtract 9, subtract 9. 12x equals 12. Divide by 12, divide by 12. X equals 1. So our solution, that's eerie. 1, 3 again. Actually, if you went through and you looked, example 14 and example 16 are actually the same equations. They've just been multiplied by some number. Well, no, they're not exactly the same equation. I take that back. Anyways, they just happen to have the same solution and a lot of similar numbers. Okay, so let's go ahead and look at one more example that's a little bit more tricky. Let's go ahead down and look at number 18. All right, in number 18, if I look at the coefficients, if I look at x's, negative 8 and 6, they're not that happy. If I look at the y's, negative 2 and 5, I don't really see what I could multiply either equation by. Well, that's because I have to multiply both equations by something. So if you look at either x's or y's, you really need to think about what is the least common multiple. What number could they both go into? So for the x's, 6 and 8 could go into 24. And for 2 and 5, they could both go into 10. It's totally up to you. For some reason, my brain just likes 10 better than 24. So I'm going to go ahead and I'm going to multiply this first equation by 5. That'll make 40x minus 10y equals negative 150. And I'm trying to get the y in the second equation to also be 10. So it'll cancel. So I need to multiply this one by 2. So if I go ahead and do that, multiply, shall I really write them up there? This equation by 2, I get negative 12x plus 10y equals 38. All right, now these equations are still equation 1 and equation 2. They're just multiplied by a scale factor. So we can go ahead and solve them by adding them together. We get 28x here equals negative 112. And we divide both sides by 28. And we get x equals negative 4. Great. So we'll go ahead and plug that back in. So 8 times negative 4 minus 2y equals negative 30. So that's negative 32 minus 2y equals negative 30. Great. We can go ahead and add 32 to both sides. Negative 2y equals 2. So we divide both sides by negative 2. And we get that y is equal to negative 1. Terrific. So our answer is negative 4, comma, negative 1. That is the place where these two lines, these two equations would intersect. So here we see we looked at the coefficients, we looked for the least common multiple that they would both become. We could have done it for either x or for y. I chose to do the least common multiple of y, but you could have easily done the least common multiple of x. Okay, so this is solving systems of equations by elimination. Personally, it's my favorite method. I think many of you will also enjoy it. It seems to be a little quicker most of the time in getting to our solution.